Find d square y by dx square. You can see power 2, 2, 2. That means it is second order derivative. This one. We need to find second order derivative. That is the meaning of d square y by dx square. Y is given. So take this first. X plus tan x. Before finding d square y by dx square, we have to find dy by dx. Take d by dx on both sides. D by dx of this y is equal to d by dx of this whole thing. So x plus tan x. Next, we want dy by dx first. So don't touch this. Keep this as it is here only. Next, since we have plus here, we can distribute this d by dx for this and this separately. This first, then this like this. So d by dx of this x, okay, plus d by dx of this tan x, okay. Now dx, so we can cancel. See, when x has power 1 here and here, so if you cancel this also no problem. Sometimes they will give x square x cube. So that time if you want dx square dx and all, so we have to use power rule, like d by dx of x to the power of n is equal to n into x to the power of n minus 1. When power of x is not 1, that time you have to use this formula. Here power of x is 1. Just x means x is equal to x to the power 1. When power of x is 1, in case of this dx by dx, we can dx cancel, so we can keep 1 directly. Okay. Plus next, d by dx of tan x. There is a standard formula. D by dx of tan x always is equal to secant square x. This you have to remember. D by dx of tan x is secant square x. This is the formula. Okay, now we got dy by dx. Okay, but we want d square y by dx square. That means we have to differentiate this once again. See here in the denominator dx is there. That means we are differentiating with respect to x. With respect to x means x is the independent variable, y is the dependent variable. That is the meaning. We want d square by dx square. We will get this when we differentiate this once again. So once again means dx is there no here denominator. So we have to differentiate this with respect to x once again. Differentiating with respect to x means d by dx of this dy by dx once again, dy by dx is equal to dy by dx of this whole thing 1 plus secant square x. Now dt, so d by dx of this, d by dx of dy by dx is d square y by dx square. Don't think here dd, so d square, but here dd is there. Why not it is d square? Okay, it is not like that. It is separate case. We are not multiplying the variables. It is differentiation. Okay, x is function, y is a function. In this case, so d by dx of dy by dx is this d square y by dx square. Don't confuse like here dd, so d square, here dd, here should be d square. No, that's not right. This is differentiation. Okay, this is separate case. Here d by dx of this will be this only. d square y by dx square. So don't confuse with d and d. Okay, next here 1 is plus is there, we can distribute this to d by dx, we can distribute d by dx to 1 and secant square x separately because of this plus sign. So d by dx of this 1, this plus again d by dx of this secant square x. Okay, so 1 is a constant, differentiation of this 1 with respect to x will be 0. Constant, if you differentiate constant it will be 0. Next plus we have to differentiate this. Here we will use chain rule. Chain rule means it is not single function, there are two functions. For example, see secant square x. Secant square x is one function. If you forget this 2, there is another function secant x. So there are two functions here. When there are two functions, we have to use chain rule. Chain rule means I will show how to differentiate. You will understand. I said there are two functions. So first consider this secant square x. See, we have general formula. It is in the form of x to the power of n. Okay. Actually, x is a function, secant x is a function. Here in place of n we have 2. So we have formula for d by dx of x to the power of n. We have formula n into x to the power of n minus 1. Okay, just assume in place of x we have secant x. In place of n we have 2. So I will write it here, d by dx of secant square x. In place of x, I said secant x, in place of n we have 2. So use this formula, in place of n 2, in place of x secant x. Okay, in place of n again 2 minus 1, this minus 1. Now this 2 secant x two minus 1 is 1. Secant x whole to the power of 1. So again this 2 secant x whole to the power of n is equal to secant x. Because anything to the power of 1 will be this only. For like how I can say, for example 5 to the power of 1 is equal to 5 only. If the power is 1, same thing 5 will come here. Similarly, power is 1, same secant x will come here. So 2 secant x we got. Okay. Write this 2 secant x now. Okay. Next I say now this function is done. We have another function secant x. Okay. So d by dx of secant x. For this a standard formula, differentiation of secant x with respect to x will be tan x into secant x. Okay. So this is standard formula. So write this here again. Tan x into tan x secant x. Now 0. We have 0. You can discard it. Plus 2 secant x. If you don't write plus also, no problem, there is no wrong. You can simply write this, only this much. Okay, you can remove the plus, it won't become wrong. Now these 2 secant x 2 times, so secant square x. Secant x into secant x, we get secant square x, and remaining is tan x. Okay, so now see, this is the answer. 2 secant square x tan x is the d square y by dx square. Okay. Thank you. Click on subscribe.